Hi, I'm Steve Wesnousky. I'm a professor at the University of Nevada Reno, and we're conducting an earthquake project here in the middle of Nevada along the Tobin Range. And many of you might consider, when we talk about earthquakes, that it's a matter of looking at seismograms and reflections and computers and computing science, but in fact, a large contribution to our understanding of earthquakes comes from the geological study of when those earthquakes actually break the surface. So in this case, behind me, there's a hillside and a excavator, and that little hillside was actually produced by a number of earthquakes. And also in 1915, along this same stretch of the Tobin Range front, there was a large magnitude 7 earthquake that produced surface rupture. In other words, it disrupted the surface, much like you see behind me, along about 40 or 50 miles of this range front. So in this case, we're excavating the trench across where the fault actually reaches the surface. And then as a geologist, and basically we employ introductory geology, structural and stratigraphic principles and ideas on how soils develop to unravel the displacement history and actually determine when the past earthquakes, the prehistoric earthquakes, have occurred, how often they occur, and how big they were. And that information, after we gain it, allows us to do a number of things. It allows us to understand how fast these mountain ranges are building, and so in a sense, it's a study of the mountain building process. But also, as we unravel the size and the timing of the earthquakes that occurred on this fault, that information goes into a large cauldron of observations that have been collected in the same manner on faults around the world, and allowing us to look at the systematics of those displacements and how long the ruptures are in that regard, and incorporate that ultimately into models that describe the seismic hazard of any particular region on the planet.